Let's talk about 1.4, factors, multiples, prime factorization, anything else that has to do with those topics. So let's dig in. We have 30. Number one was asking you what are the divisors of the given numbers. So this is like 30. You can write 30 as 30 times 1, 2 times 15, 6 times 5, 3 times 10. Those are different ways to represent 30. Now, what is interesting is in number 2, for example, they ask you about 19. Well, 19 is a prime number, meaning it can only be divided by itself and 1. So 19 times 1 is 19. You have situations where they ask you what are the numbers that multiply to give you something. And I apologize, this is number 2, not 12. But 19 would be 19 times 1. And then we look at number 4, where they ask us about 51. In order to know if 51, the different factors for 51, it's good to know if 51 is divisible by a certain number. And we know that 51 is divisible by 3. How do we know that? Because 5 plus 1 is 6. 6 is a multiple of 3. Therefore, 51 is divisible by 3. So for 51 in number 2, we can say that the numbers that multiply to give 51 include 51 times 1 as well as 3 times 17. So that's what they're looking for in this section. We're trying to take each one and we're finding the factors that multiply to give that number. This will be a very good time to review your divisibility rules. That is very good to keep in mind. The divisibility rules. They are included in your Tools for Mastering Mathematics book, and make sure you review that. This is in the reference section, which I can provide the page number when we get to the next section. So, for example, the divisibility rules on page 29 of your Tools for Mastering Mathematics book, we are told that if a number is even, for example, then it is divisible by 2. Right away, we know that. If a number is, if the digits of a number add up to a multiple of 3, then that number is, we know that that number is divisible by 3. So, for example, 711, you just add up the digits. You get 9. 9 is a multiple of 3. Therefore, we know that 711 is divisible by 3. So it's something to keep in mind as you look at the different sections that you're working on. So number 1 to 12, those problems are dealing with, again, writing out numbers and their factors. One of the best ways to know numbers and their factors is to actually prime factorize the number. And the number, when you prime factorize the number, you get a certain set of numbers, right? So for example, let's take this example here. If you take the number 24, if I ask you what are the factors of 24, one way to do it is to break 24 down. Okay? After you've broken it down, you recognize that 24, first of all, is 2 times 12. We know that, right? But 24 times 1 is also 24. But you know that there's a 3 that is embedded in 24. So you divide 24 by 3 and you get 8. 8 times 3 is 24. The other number that you have to keep in mind is you look at it and you go, wait a second, there's a 2 and a 2 here and a 2 and a 3 here. So that's 4 times 6. These are different combinations that will give you 24. If you multiply any of these, you get 24. So that's something to keep in mind. Then exercises 13-20, for number 13 to 20, they ask you to find which of these numbers is not divisible by 2. Which of the following numbers is not divisible by 2? Well, remember, for 2, you just need to see that they're even numbers. If two numbers are, if a number is even, meaning that it ends with 0, 2, 4, 6, or 8, that number is divisible by 2. No problem. And then for 3, we basically add up the digits. So that's for 2. For 3, you add the digits and see if you get a multiple of 3. If you get a multiple of 3, then that number is divisible by 3. For 4, we want to see that the last 2 digits of that number are divisible by 4. If they are divisible by 4, then we expect that the number is divisible by 4. For 5, the number has to end with 0 or 5. Again, this is on page 29 of your book. As you get familiar with these, you will get faster and more efficient in multiplying, dividing, and working through things. So remember to use these reference tools to improve your math skills. So we have 5, we have 4, we have 5, we have 6. for 6, if the number is divisible by 2 and 3, then it's divisible by 6 as well. Now, 7 is very interesting. Some textbooks actually don't tell you the divisibility rule for 7, so feel free to look at it and you'll find it to be very interesting. You double the last digit and subtract it from the number that remains. If the subtraction is 0 or divisible by 7, then the original number is divisible by 7. It's very interesting. Then for 8, 9, 10, 11, 10, of course, you have to have a 0 at the end. But all the other ones, look at them and then just begin to use them as you need to, and you will get very good at this. So for exercise 13 to 20, they're asking you about divisibility by 2. For 21 to 28, divisibility by 3. You just add up those digits. For 29 to 36, you can look at the last two numbers. Are they divisible by 4? And then for number 37 to 44, we need a number to end with 0 or 5 in order to be divisible by 5. And then they ask you for 6, 8, and 9. So just pay attention to the rules. And, I'll have another video for you that talks about divisibility rules. Just feel free to watch it and see. Otherwise, the only other way to do it is to take each one of those numbers and just divide them by the number in question. Now, they give you a set of numbers. So if one of them is divisible by 9, for example, the others will be divisible by 9, most likely in that group. Or they'll give you ones where if it's not divisible by 9, then the rest will not be divisible by 9. So keep that in perspective. So we move now to number 69 to 80. This is from 1.4 in your book. For 69 to 80, they're asking you identify the given number as a prime, composite, or neither. So 19 again, that's prime, right? There's a way to find out or get more comfortable with prime numbers. We know that 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31. So these are called like twin primes. And then we have 37, 41, 43, and 47. So there's more. There's not necessarily a pattern that you can observe. Some cases like 2 and 3, of course, 2 because it's the first even number and the only even number that is prime, because there's nothing else that goes into 2 apart from 2 on itself. So this is just a sample here. We give you some prime numbers. We give you the ones for the first 100 in our book, Tools for Mastering Mathematics. Just get comfortable with knowing how to recognize prime numbers. One way to recognize them is to see, can I divide this by 2 or 3 or 4 or 5? And if you notice that you can't divide it by any other number and you're comfortable with your division skills, then most likely that number is prime. Number 81 to 98, which is the next section, says find the prime factorization of the natural number. You just take the number like 128, for example, and you can break it down with a factor tree. And you have 2 and 64. You break that down further, 2 and 32. You break that down further, you get 2 and 16. Break that down further, you get 2 and 8, 2 and 4, and 2 and 2. So we see that 2 times 2 times 2 times 2 times 2 times 2 times 2. So that's 2 to the 7th power. You can write it in exponential form if you want, and that's how we do those problems. We can use a factor tree or factor ladder. I grew up in a country where we use the factor ladder. In Nigeria, we use the ladder a lot. 2 goes into 128 64 times, and so on and so forth. We go down the ladder. This section has a few numbers for you. Make sure you practice, get comfortable with it, use the same strategy. Try both, see which one you prefer. The next section from 99 to 110 is talking about things like when they give you 5 squared times 4 to the first. It just means that, of course, you write 5 squared as 5 times 5 and then times 4. So 5 times 5 times 4 is 100. So they want you to compute these numbers where they give you the exponential form. You multiply it out, and then you multiply and you multiply the other one, and you're good to go. So that's what you have to do for number 99 to 110. A few more things for us in this section. I would encourage you to do number 123. It's a good exercise, and it's called the sieve of Eratosthenes. Basically, you take the first 100 numbers, and you take a number like 2, for example, and once you've taken a number that is prime, you cancel all the other numbers that are multiples of that number. So, for example, we're going to cancel off 2, 4, 6, 8, any number that is a multiple of 2. Then you take 3. You cancel off any multiple of 3. And you do that for, as you keep going. Eventually, you're going to be left with only certain numbers. Those numbers are most likely your prime numbers. If you do the exercise well, you get only prime numbers. So keep that in perspective. 2 more things before we wrap up. They give you more practice, right? The prime factorization for each number in compact form using exponents. They give you a number like 12, for example. You can break that down and you get 2 times 2 times 3, or 2 squared times 3. So keep that in perspective as you do those problems. Write them as exponents. And then finally, for number 111 to 114, find the area of a square with the given side. If the side is 28 inches, you just say 28 times 28. Make sure you're working your notebook. If you have any questions, please do not hesitate to send an email or reach out. Thank you for your time. Have a great day.